Oh my God, I'm so tired from waving. I don't know about you, Ben.
Oh man, what a day. But it's been nice to finally get to talk to you, David. It's been a long time. I mean, we talk about, I don't know, every other week about, things like Armchair Architects and various Azure Enablement Studio videos. But today we get to talk about something really cool, the introduction to the Microsoft Well-Architected Framework. So
Yeah.
um, yeah, I mean, holy smokes, it's finally here. We did a big refresh to the well-architected framework last month or in November, and we did a Learn Live event like this with you and Jason. Uh, I forgot his last name at the moment, but the two of you guys did it about 18 months ago, and so now we're going to do kind of an update to that. So very
Yeah,
happy to
it's
be.
good. It's good. This is sort of like Learn Live plus plus, because not only are we going to go over the stuff that you find in the module, we're also going to give a real special look at the new stuff that's in here, which I think actually makes the WEF like so much better. So I'm really excited to do this. So let's introduce ourselves. So I'm David Blank-Edelman. I'm a senior cloud advocate sometimes I'm a technical program manager here at Microsoft. Ben, do you want to say who you are?
Well, before I think one of the cool things about what you do on kind of as your main job is that you're highly involved with a lot of the reliability and SRE things that happen around Microsoft. So, I think it's a good thing to toot your horn about. I'll do it for you. But so yeah, we'll probably dive deep into the reliability piece. So I'm looking forward to that. I'm a product marketing manager for Microsoft. I focus a lot on the well-architected framework, but I also have spent quite a bit of time on the cloud adoption framework and the architecture center. So everything that we would call patterns and practices, basically here at Microsoft. So what we're typically doing, and if you've seen the previous episodes, we've spent a lot of time talking about optimization as part of this Learn Live series. And so what we're going to do today, again, is talk about the well-architected framework because it is a major part of optimization.
Yeah,
So
and we'll
let's,
go over what it is. We'll go over why you care. We'll go over why it can be easy and why it can be hard in equal measure. But I think we should. So let's move along. We have to introduce somebody very special first
yes, yeah.
before we continue. Everybody wave to Sarah. Sarah is being kind enough to be our moderator today, and she rocks, and we really appreciate that she's behind the scenes. So if you think we're really good, you should see what she's doing behind the scenes. It's really great. So
Yeah. She has done a virtual training day for optimization, where well-architected framework is a big part of that, and so she knows this content really well. And so yeah, if you have questions, send them on to her, and I'm sure she'll be able to help answer those.
yeah, yes. Okay, thank you, Sarah. Okay, so if you want to sort of see stuff, including the actual module this is based on, here's the URL. Here's a QR code. It does not go to Rick Astley. It does, in fact, go to this particular module, and we encourage you to go check it out. But I think we should get in. Let's get into it. I'm like too excited by that.
Okay. Yeah. I think also one of the things about the Azure Well-Architected Framework is it's constantly evolving. And so the Learn Live and the Learn module here, you'll find that it also has been refreshed. So if you haven't, or if you've gone through the Well-Architected Framework already and kind of gone through this Learn Live session, go back and look at this module too, because I think you're going to find a lot of interesting content beyond what we talk about today.
And just to be clear, this is not going to be the audiobook version of
Right.
the Learn Live module. We're going to do our best to sort of bring to you stuff that isn't in this, add some color to it, give you some sense of what's behind the thinking behind it, things to really pay attention to, which is important as far as we've seen working with customers and other people in our own backgrounds. So this will hopefully be like, like I said, plus. So here are the learning objectives. I mean, our fond hopes is that you'll go a little deeper than just can describe, and you'll be able to identify like, oh, look, there's reliability. I think we're going to get a little bit more subtle than that. So look forward to that in this thing. So
All right. So, quick introduction. So, what we're trying to do basically is think about the the way you think of a well-architected workload. It's a workload that has a system that you're either going to run on cloud or in or on premise. In this case, where almost everything we talk about is going to be in the cloud. And so, one of the things that a lot of customers are trying to do is figure out how to take an existing application or workload and move it to the cloud. What sort of architectural design principles that need to be considered as you're moving into this more dynamic, highly scaled environment? And so the well-architected framework helps with that sort of model.
Yeah, and I want to say, even though I have the cloud behind me, I don't know if you know, this is what Azure really looks like. Most people don't actually know that, that it looks exactly like this. But um, the secret is that stuff we're going to tell you now really will help you in all of your running of the sort of workloads. We're using workload as our official way to capture like an application or a group of applications working together, a service. There's lots of words you could use for the same thing. We're using workload because it just happens to be the thing associated with that. And so so the reason why you care about all this stuff is at some point in time, you're going to be responsible for either creating or running or operating some workload, perhaps in the cloud, perhaps not. You may already be, I suspect you're already something like this as well. And you're like, okay, well, what do I have to pay attention to make sure that things are reliable, that things are secure, that things are run well, that I'm not paying too much money for what I'm doing, that my performance is good. And to get there, what we put together is a set of pillars. These are the ways we break it down as we think about it in a set of pillars. And that's going to sort of set the stage for all of the different sections of what we're going to talk about today. So what are the pillars, Ben? So let's go back one more. So this is the list of pillars. You'll see this in the module as well, right? I mentioned those a moment ago: security, reliability, performance, which is also efficiency in many ways, operational excellence, how you're running things, and cost optimization. And we'll talk about these things because it's really easy to put this on a slide, but it's a lot harder to do in real life. And so we're going to do our best to not be very glib about like, oh yeah, just make things secure. Right? Like that's not useful information to you. We're trying to give you real information. But these are sort of the things that, to our mind, make up what a well-architected application or workload is. And the thing to know about well-architected that's really important is that what we're trying to do is describe the state you want to stay in. That's what we mean by well-architected. We don't mean like build it once and it's good, because anybody who's ever done any of these things knows it doesn't work like that. The way it works is you're constantly in a process of trying to make sure that things stay in the right state. And this is a good way of understanding whether that's true or not and what to pay attention to be able to do that. So it's not like an architect, who knocks on your door later and says, hey, can I help architect some more? It's more like, okay, well, what do we have to be paying attention to now that we're running it, now that we've, both from when we started to figure out what we wanted to do to actually running it to getting rid of it, through the entire life cycle, you have to maintain it in a well-architected state. And that's what we're talking about when we talk about the well-architected framework. So money, right? Like this is cost optimization. And one of the things that, when we'll go deeper into this later, but one of the things that's really key to know here is we're not talking about, we're not excluding, like, how do I make my bill cheaper? Right? It's not, like that's good too. Like don't get me wrong. Like that's an important thing to know how to do as well. But it's more like, am I getting the value for the money that I'm spending? Because it's perfectly reasonably spending money. It's like a cost of business, right? But you want to make sure that that you're getting the bang for the buck, right? And there are ways to do that, and there are ways to not do it. And it's very easy, if you're not paying attention to it and not doing it intentionally, to have a bill that's sizable and to feel like I'm not getting what I paid for. And that's not something anybody, especially Microsoft, wants you to feel. So we'll be diving into that. Okay, I was going to say operational excellence. So this is something that I dig coming from the site reliability engineering world, which is what can you do to make sure that you're running it using processes that are that serve you well, that get you the reliability, that get you the speed of the velocity of feature releases, that gets you the value that you're hoping for. And there are lots of different development practices and operations practices. DevOps is mentioned here. I've mentioned SRE. We'll go into all that stuff later. This is just sort of set the scene for you, so know what the sort of things we're going to talk about. Next pillar, please. Performance efficiency. Again, this goes a little bit towards cost optimization in some ways, right? Because again, the question is, are you spending your money well? And if you set things up that are not performant and it's not behaving as well as it could, well, that's probably not efficient. It's certainly not cost effective. And so there are ways to build architectures or to work into your workload things that make them more or less efficient. And we will talk about that as well.
Yeah, I also want to point out with performance efficiency that when people think about scaling and why go to the cloud in the first place, they often think about the ability to scale, and they want to be able to do that as flexibly and as agile as possible. And so performance efficiency is one of those things where people just say, okay, now let's go turn it on, and we'll be basically able to scale as much as we need to. And oftentimes what we see with that kind of behavior is actually code that can be written pretty inefficiently, or the code itself is relatively inefficient. And so that there's the reason why we've included performance efficiency is so that people realize that when you think about the architecture, you need to be also thinking about the code that you're running for the particular architecture within the cloud. It's going to have certain performance issues, and that would be okay if you're willing to just continuously scale it out. But what is that going to do to your costs, and what is it going to do to the way you think about other aspects of the effectiveness of the application? And so performance efficiency is one of those areas that we do spend a lot of time thinking about cost, and also other aspects of what it means to scale back. So we'll be talking a bit about that too.
Yeah. My favorite. I think this is actually other people's worst fear as well. That and public speaking, I think, is way up there. But seriously, the way I put it is, you can spend millions of whatever your local currency is to build the best system you can, to hire the best devs, to have them churn out the best features. You can hire the best people to support them. You can hire an entire sales group. That's great. You can do it, around the world. And then when it goes time to turn on your thing or to have the service be working, and if it's not working, well, all that money sort of goes down the toilet, right? And so reliability is one of those things that is really crucial, because if it doesn't exist and it's sort of an emergent property, then all of your efforts go to naught. And so that's why I particularly care about it. But I think that you will want to have a really good look in this. And it's not also trivial. That's the other thing. There's no button that says make reliable on Azure or any other cloud provider or on-prem that I'm aware of. If there was, that would be really cool. So it takes some thinking and some doing and some planning. We'll go into that later.
I did have one question for you. A lot of people, as a reliability site reliability engineer, one of the things that people often confuse is, what's the difference between reliability and resiliency? Like, I hear a lot of people say, let's just be resilient. What is that?
Yeah. So it's funny because this is kind of a trigger word for me. So resiliency often gets used, I think, somewhat inappropriately to mean fault tolerant, or maybe like there's various versions of what a resilient can mean. Like it can mean robust, it can mean rebound, like if something goes wrong, it fixes itself and it's fine. And so that's perfectly useful to understand. Reliability for me is this emergent property that describes not only that, but is your system meeting your expectations? So if a system, for example, has a big privacy breach, it's not reliable from my perspective, which is different than fault tolerant. Like if it is the case that one of my servers goes down, but the other one is still improperly serving data, that may be resilient, but it's not reliable from my perspective. So it's about meeting expectations for me. That's where it comes to. Now, resilience is important, but as I said, we kind of use it in this very colloquial way. I think if you look at stuff like resilience engineering and that whole discipline, there's a much more interesting idea that resilience, in addition to being just fault tolerance, could be adaptive capacity. Like, so how do you handle a surprise? What happens if something happens that you don't expect? Is your system built in a way that it can respond using some adaptive capacity that already exists in the system to handle this? The best way I heard about this, and then I know we're going to move on because we could just spend this entire time on this slide, and I'd be perfectly happy to do that. Is John Allspaw was in a talk, and he was talking about, like, hey, having a spare tire isn't resilience. That's fault tolerance, right? Resilience is knowing how to work with or maybe that's just redundancy or high availability or whatever. Resiliency is having a knowledge of transportation systems so you can get done what you need to get done, right? So if your tire breaks out and you have the ability to know how to get on a bus, right, which is to me more resiliency than I can just replace my tire, right, which would be sort of fault tolerance. I hope that answers your question. Let's come back to it later if we get into the reliability system. If people have questions about that. So,
okay, let's do that. Okay, yeah. Tell me about security. What do you think security is about?
Oh, I don't know. It's about springs. Can't you tell on this slide?
Go ahead.
Yeah, I mean, this slide has always given me a little bit of agita because this is like the fear slide is what it is. It's like it's all about fear, right? And security doesn't have to all be about fear. I agree that data is the most important piece of your organization's technical footprint, sure. And security is in many ways making sure that the right people are doing the right thing with the right whatever, and that we don't get that. So, but I think this is one of those things that people now get. Like, if I have to say, like, is security important? There isn't a person I have met that's like, yeah, I don't know. I don't. Sometimes we have secure systems. I go to my bank and sometimes they leave the money out on the corner and sometimes they don't. It's cool. So we all kind of understand that, luckily.
And I think the other thing that we're hanging on a lot of, and it's definitely talked about in the pillar, the security pillar, is that security is becoming more and more integrated into the organization as a whole. For a long time, SecOps, the SOC was kind of off on its own. The security operations center was always one of those disciplines, functions that kind of had its own set of people that kind of knew what they were doing in the security space, and that was that. These days, because security is so integral to cloud and cloud operations, it is an important interdisciplinary.
Yeah, I know these are. I know that I can't say any of that either, but I definitely agree with you. I mean, yeah, and you'd like to think that reliability is getting there as well, right? But it is for sure part, interdisciplinary. I think is where you're going and hooked into that. So,
yes.
And there's different, but there's lots of aspects to it. And I think the thing that security gets a bad rap is like the people who say no. And that's their job, and that's not their job. Their job is to figure out, just like the people who care about reliability, their job isn't to say, you can't do that unless it's reliable. It's like, how do we do this in a way where we can move ahead in a way where we feel not scared, I guess is the direct way. Okay, next pillar, please, because we are at this place and we're not very far into our thing. Okay, so this is just a general thing. I recommend you take a look at the module. It just basically says, like, in addition to the pillars, it's really cool if you make sure that your data does the right thing and you have education and you enable it, and automation is really important, and make sure that you are working on your architecture. I think none of these things are super surprising to anybody on the call, on this thing. So.
I think what this particular set of general principles is relating to is the cost, or the operational excellence pillar, and so we'll talk a little bit about that too, as part of how the operational excellence pillar is integrated into the other pillars, such as security, reliability, and cost, and of course performance efficiency.
Yeah, we'll get there.
Yeah.
Shared responsibilities. this is another one of those conversations. What it's just trying to say is that Azure has some levers it can pull and some products it can offer and some features behind the scene that it can do to try to improve the well-architected nature of your thing that we encourage you to make use of. So for example, with reliability, we might say, make sure you're using availability zones to make sure that you're reliable to certain kinds of failure. And if, that's important, we provide it. We spend a lot of time trying to do that. And then the other side of it says that, like, hey, there's things that we on the Microsoft side can't do, which is help you write the code that takes advantage of those, or doesn't take advantage of those, or is written in a way to handle situations, or is written efficiently. And we want to do what we can to help you with that. And that's where the shared responsibility comes. It just says like you have certain levers to pull, we have certain levers to pull. We're doing our best to make sure that we talk about that with you. But there's no expectation that like customers have to walk into the data center and keep things running really well. That's our job. Right. And we work on that very hard. So.
Yeah, and one other part to this, from an architect's perspective, this is actually a really important area to remember is that, and this is also described in the Well-Architected Framework, is the shared responsibility is not just between the customer and Azure. It's also related to how does the different teams, like the workload teams and the central IT teams, work together. So, like one of the things we talked about in the first and second episodes of this series is how does the cloud adoption framework kind of help set you up, your organization? How does it set you up to do things like ensuring policy, ensuring the way you go about using your landing zone? So Jeff Mitchell and I talked a lot about what does it take to set up a landing zone? Why do you have a landing zone in the first place? And so a lot of reasons why we're talking about that is because of this shared responsibility. But then when you think about it from the architect's perspective, there's also this need for the workload team to understand how to architect the workload such that it is running in an environment that is meant for it, or that's appropriate for it. So
right.
That's where you start thinking about, okay, there's a difference between a platform landing zone and an application landing zone. So the architect's going to be much more attuned to and be thinking about the design of the application within that application landing zone. So what are the configurations of that application landing zone, and then how does it supports or enable that workload and the architecture of that workload? So that's one of the reasons why shared responsibility is actually discussed throughout all of the different patterns and practices that we have within Microsoft and Azure, is because there's different dimensions, different perspectives on how shared responsibility needs to be employed across the organization.
I agree. My fear is, see, the problem is all these slides have lots of really good things to talk about, and so I want to make sure that we actually get to the pillars, for example. And so just a note to ourselves that this is really, I mean, I'm hoping, let us know in the comments whether this is the sort of thing you're into, because like you don't get this sort of depth out of just the module. So we're trying to offer that as well. Okay, Ben. So let's move ahead at whatever clip you want.
Okay.
Yeah, right. Do good design choices. Yes, there you go. That this is like do the right thing slides. So let's move right past this because stuff like that. Okay, we're into cost optimization. Now we get to talk about the dollars, and it's good that there's a reason why we're starting here first. This is one of the places where we know for a fact someone is going to walk in with the Azure bill and put it on your desk and say, what's going on? If you haven't paid attention to this, or if you're not aware of this, right? It's one of those things where, because it's possible to spend infinite money, and because businesses care a lot about the money they spend, that we want to make sure that everybody feels good about their, how they're spending in Azure and as part of the Well-Architected Framework. So that's why this comes right up front, because this is one of the places where the rubber hits the road, or hits the PO, and you want to make sure that that you're paying attention. So let's look into cost optimization if we can. So Right. There it is. It's the like, hey, it's the what the heck pillar, right? And we're here to make that not happen, right? So we want to just make sure that, again, it's used to maximum effect. Like, yes, smaller bills, good, we get that, but also getting what you want out of what you're spending is even better, because if this was all, yeah, anyway, you have to spend money, make sure you're spending it on the right things. And let's talk about how you do that.
Yeah, I just wanted to also point out that there's been a lot of conversation about it. Is it really, are we really talking about optimization, like cost optimization, where we're trying to save money, or is this really about efficiency like ensuring that we're using our dollars, using the investment in our cloud infrastructure, or into the cloud as efficiently as possible? And so
Yeah.
the efficiency notion, back to what you were talking about earlier with performance efficiency, that's why they're so well related. Is that it's more about efficiency of how you're going about operating this workload, and also how do you design so that the workload is operating as efficiently as possible. And so that's really that's what we're talking about when we say cost efficiency or cost optimization.
Yeah, and I just want to say it's cost optimization, not cost reduction, for a reason. Yes,
Right.
we're all for the reduction part, but that's why the word optimization is there and not reduction. But let's go deeper. Can't tell you anything you don't know. This is another one of these slides from these things that I feel like, like it's good to know that you're going to spend money and how much you're going to spend. And there's really useful ways to do that, like cost calculators and et cetera. That's not the thing we want to show you about optimizing per se, because, you know this already, right? And if you don't, let us know in the chat that you don't know. You have to pay attention to what you're going to spend money on. So this is also the thing that just basically says, do the right thing ahead of time, and I think that that's useful to say, that you should provision them optimize from cost from the outset. But I think also, in my experience, people tend to find this to be a learning process, like over time. Like they'll put something out there, they'll be like, oh, I see, I could have done it this way. So I don't think I've met very many people who have gotten it right out of the gate. And that's why we call it optimization, not like provisioning, cost op provisioning, right? Like it's meant to really say, like, I'm glad you should think about it when you're provisioning, but I also want people to understand this is an iterative process, which is where we're going to get into some tips on how to do that in a second. This says pay attention to your money. Again, probably something right? There's some really good stuff in the cost center, stuff on the portal, that helps you track your costs and set budgets and stuff like that. And so here's where we get to kind of the important thing about efficiency, right? This is trying to say that there's a number of things you can do to be more efficient with how you're doing it. So, for example, if you have things that you have provisioned that nobody's using, or licenses that nobody is using, or you're putting data out that you never touch again, or you just keep on running the same stuff over and over again, well, those are places that you can probably be more efficient, right? And you can shut down, or you should shut down temporarily. Examples of this, which I think we might even get to later, is if you know that your developers only work from 9 to 5 on Monday through Friday, is there a reason why your dev environment is running on the weekends and spending money? Probably not. And there are ways to automate that so that it comes and goes. Or if you need an environment up all the time, or can you push a button and have it show up in the next 10 minutes, and therefore all the time when you weren't using it, you're not spending money. So there's lots of ways to do that. And so that's what we talk about. And the nice thing about that, this is one of the differences between on-prem and cloud stuff, right? Cloud has sort of like faster provisioning in many ways, as opposed to like, I'm going to drive the truck to my loading dock, unload new servers every time I'm going to bring an environment up, and then take them out again. It doesn't happen, right? So that's why we think cloud is cool, among other things. But okay, let's keep on going in this thing. Oh yeah, knowledge check. Good. Let's do a knowledge check here. Are we ready? Are we excited? This is a thing. This is for you who are watching us. We want to make sure you have knowledge. So demonstrate knowledge. Which of the following actions is an example of waste resulting in an increased resource cost? A, archiving infrequently accessed data to an archive storage tier. B, using a service that automatically adjusts resources that are provisioned to match user load. C, pulling databases to sheer provision capacity. Or D, running a development environment overnight that is used only during business hours. Feel free to, for sure vote on this. I know which one I vote on. Feel free to do the actual poll. We'll actually see you do that, and we'll get to see little things move. It'll be cool. Or you can say in the chat whatever works for you. Yeah, I think the chat is pretty uniform on this one, and I can't disagree. That is correct. The other ones are not waste; they're good things. And look, it's in green. So, okay, let's move on. Which of the following practices is a good way to reduce costs? A, conducting regular reviews of cloud bills to identify abnormal increases in spend. B, letting all IT teams have access to provision virtual machines of any size. C, provisioning the same capacity in development environments as for production, even though resource requirements are substantially lower in development environments. Oh, that's a tricky one. We could talk about that one. Or D, provisioning virtual machines that include licensing costs rather than using a bring your own licensing image. Well, what would you guess would be a way to reduce costs? I think you could probably guess that. Yes, indeed. I want to say that C is a little funky to me. It's trying to tell you, like, hey, why is your development environment, your production environment look the same? And I'm just here to tell you that that's not always good advice to keep one smaller than the other, right? Especially if you're trying to make the scaling decisions, if you're trying to do honest to goodness load testing, et cetera. It may be the case that there are times where you want your production and your development environments to be identical, because otherwise you have to put it in production before you find out whether what you learned in development is correct, which is, shall we say, not the best way to do it. Anyway, that's a really fun one, and I hadn't thought we were going to have in there. So, okay, let's move on.
I think we have 2 more to go.
Suppose you recently moved your application to the cloud and your monthly bill seems higher than expected. The utilization level of your VM, I guess you have just one VM, is high enough that you are hesitant to downsize because you only got one VM. What might be a reasonable next step you can take to help find inefficiencies? A, wait a month and recheck your bill. B, increase the amount of application testing you do before it's released. Or C, add monitoring and instrumentation to your application. Well, yes, indeed. It is pay attention to the thing. I mean, we know that some of these questions, we're hoping that some of the, like some of these questions are easy and some of them are obvious, but some of them, like the last one we did, do have some answers in there that hopefully cause a little bit of thinking to take place. That's my fond hope, at least. Okay, moving on. Another pillar.
Yeah, we're now into operational excellence. I think what'll happen, what will be great is if we can, get through the pillars and then we can actually go into the framework and do a demo of the framework. So I think, we'll continue to move fast through these slides and get through the knowledge checks, and then we can get right into the demo.
Demo. Yeah, totally. Okay, operational excellence. So operational excellence, I'm not even going to read what's on the slide because I've been in operations for nearly 40 years. So I have an opinion on this, right? And the basic deal is this, is that it's really cool that you provision stuff, but in my experience, you got to operate it too, right? And operational excellence is, do you have the processes, procedures, the know-how to run things well, right? Because running things poorly, you can guess where that's going to go. It's the same deal as the other stuff. Like if your things are insecure, it's not going to be a happy time at whatever organization you're at, right? Same deal with operational excellence. And paying attention to it, because it's not just going to magically appear by itself, is where this is coming from. So keep on going. I don't know what this thing means. Let's go to the next slide. What is operational excellence? So this is really interesting that this is trying to focus on the monitoring and the observability aspects of your application. I don't disagree with it. When I talk about site reliability engineering, getting into reliability work, I talk about the importance of monitoring and operations to know, are things getting better or are they getting worse? Did the thing I do make a positive or a negative change? So I think it's reasonable to say this, but there's more to operational excellence than just knowing what's going on, because in some ways, this is a very reactive thing, right? If you're watching your thing running already, right, and it has a problem, you are reacting to it. So there are other things you can do about operational excellence. For example, making sure that your process for testing your code in your application before it gets to production is well done. So maybe, you're not going to avoid all outages, but if you can keep a couple of them from getting to production, that will be better. And that to me is operational excellence. That includes that as well. Okay, moving on.
Oh, can I just add a couple
things?
Yeah,
go for it. Sorry. I'm just
yeah. And we do want to move through the slides quickly, but I just wanted to just also point out that this is actually where you'll see a lot of comments made or references made to things like DevOps. DevOps is one of those areas that we've talked a lot about over the years. I think there's probably about 15 years of conversation around DevOps. But what we've done within the operational excellence pillar is really pull out, what are the main principles of things like DevOps? How do they relate those to Azure, and just architecting your workload, but also what does it mean to actually put it in production and continuously run that application or operate that application in production? So the DevOps component of this is actually a pretty important part. Along with that is, and this is where we talk about the update of the well-architected framework, is we actually we're beginning to reference a lot about how to create that application landing zone and then apply that application landing zone within the context of the workload design. And so you'll see a lot of those sorts of ideas and concepts and recommendations in the operational excellence pillar.
Yeah, because it's really cool to do stuff before it becomes a problem, right? Like in many ways, I think is the simple beer of little brain and way of thinking about it. Okay, so let's move on for this one. Right. Everybody kind of knows like good to use new thing, you use the modern operations practices. I think that's reasonable. Continuous integration or continuous, CI/CD is definitely a tool that we've all kind of decided if you're building your own stuff. Now, I want to point out that well-architected framework isn't just about like assuming you have your own development process. Like this stuff applies also to situations where you're like using service, software as a service, right? Which obviously we provide as well. There are definitely, you want to be monitoring that stuff too, right? Even if you're not personally running that, you want to be monitoring, you want to know when there's a problem with, you want to make sure your cost is, you're using it efficiently. There's lots of things that go with that as well. It's not just when you're building stuff out. So when we say CI/CD, that's really for, the crowd that is building their own stuff and putting stuff into production from there. But sometimes into production means I've clicked on the thing in the portal, and it's important to know that all this is applicable there as well. Okay, so let's move on from this here. Right. Okay. We said this. We said make sure you monitoring good. I don't think anybody's going to disagree with that statement. And there's various ways to do it. Like you should build the stuff into your application to make it easy to monitor. There are some really nice tools and SDKs that we offer that allow your application to just start spitting out really good telemetry, and then from there you can see some really cool stuff because they'll be collected by our stuff in Azure Monitor. This is if you're assuming you're doing the Azure thing. There's third parties are also have really good stuff. So, do the right thing. Next slide, please. Yes, this is a whole hour worth of conversation. I agree, as someone who's done this for a very long time, that automation is important and useful. And I'm also here to tell you that it has its own complexities associated with it and has its own things you have to pay attention to it. So automate as much as is appropriate of your architecture as is possible is the way I would insert into this sort of thing. Some things may or may not be great to automate. Sometimes people automate, like for example, automation that just restarts your app once a day because for some reason it has a memory leak in it and it has to be restarted every day. Yeah, I could automate that, but really, the right answer to that question is fix your memory leak. So, the way I think about it is in Fantasia, right? There's a lovely scene in Fantasia where with the brooms, and Mickey is the sorcerer's apprentice, and there the whole thing gets out of control because of essentially automation. I use that as a really good cautionary tale, and I love that part of that movie very much because I think it's a good cautionary tale that automation is great, but it needs to be done thoughtfully, is what I would say. Okay, next slide if you want. You should include testing your application deployment and ongoing operations. I think this is probably not, I don't know how many of you are using the YOLO method of development. I suspect none of you. So yeah, but it turns out that testing and application deployment and ongoing operations is non-trivial. End-to-end tests can be non-trivial. Doing things that involve identity and that sort of stuff can be non-trivial. So I don't want to make us seem like we're just saying like just do it. Like we understand that there's work to it, and there's a bunch of advice in the well-architected framework about what would be appropriate things to test, setting up sort of a model of health or health models and how to work with those. And I encourage you to take a look at those to go a little deeper than we're going to be able to have time to talk about today. Okay.
Yeah. Yeah, just one last thing about this is, so a lot of people are talking about chaos engineering and using chaos engineering as a way to test your application, test your processes before going into production with a particular type of workload. That's an important concept, and it's talked about a lot about in the operational excellence pillar. But there's more to it than that. I mean, you need to know kind of what you're testing for, how the environment's going to be set up, and to actually use fault injection in a way that it is useful, because it's not just a matter of creating chaos. It's actually
Yeah.
understanding what's the root cause based on what you've injected. And so
Yeah, or at least the contributing factors. I guess I'd say that like chaos engineering is not breaking stuff in production because it's fun, right? It's a
yeah,
process of doing scientific experiments in which you're trying to understand what you don't know yet. What are the edges of the things you don't know? How will my environment behave if things I didn't expect happen, like latency goes up by 50%, or I no longer can talk to Active Directory or Entra, right? Or maybe there's a problem where I run out of memory. And the thing is like being able to figure that stuff out before the internet does it for you is I think really valuable. But it also is not useful. It's not the sort. It's like a chaos experiment that is not useful is if I already know that my application is going to fall over when I turn off my database. Turning off my database is not a chaos engineering experiment, right? Now, how long will it take before it falls over? Now, that could be a pretty good experiment. And so you have to already have to be this tall to ride this ride, right? You have to make sure you've already made the attempt to build in the redundancy, to build in the fault tolerance that you're looking for before you want to go test it. Just like throwing random stuff at your app and seeing what happens, not chaos engineering. Maybe a fun weekend, but not chaos engineering. So.
Okay,
let's do a knowledge check.
Right, this is for operational excellence.
Right, I'm ready. Okay,
right.
Which of the following is a good example of testing in your environment? Waiting for users to reach out to you with reports of errors in your application. Oh, come on. Performing functionality tests in the development environment that are different from functionality tests in the production environment. Omitting infrastructure deployment from test plans. Yeah, that anything with omitting is going to be really good. And performing regular security tests of your application code and development in production environments. Well, sure. I think we all get this one. Is there anybody here who doesn't get this one? Raise your hand if you didn't know which one it was, and Sarah will send you a free, I don't know what. Okay, next. Which of the following examples uses automation to improve operational excellence? Manually provisioning development environments every day for your development teams. Logging on Linux VMs after deployment and installing the software packages that are required for the application, which looks a lot like the first one. C, using a configuration template to deploy infrastructure in each environment. Or D, manually copying application binaries from your build system to your deployment infrastructure. I did not throw you under the bus for free stuff. Anyway. Okay, C, we're good. So let's keep on going. Thank you for your questions. Okay, now we're in performance efficiency, right? And the thing that you'll find about performance efficiency is it's pretty darn wide in terms of what we can be talking about. So we're going to talk about just certain corners of this world, because doing performance stuff, like you'd find in, say, Brendan Gregg's book on system performance, which is phenomenal, is different than figuring out how to do scaling, which is different than figuring out, are my database queries what I want, what they need to be? Do I have indices in place? So let's just go to performance and efficiency. As I notice, we have, we're moving along here. Imagine a news story is published about one of your organization's recent product announcements. Okay, I'm going to imagine that. Now I've imagined it. Let's move to the next slide. What they're just trying to say is, what are you going to do when what are you going to do when your stuff is really popular, right? And you haven't scaled for it and haven't really thought about it, right? This is the basic notion here, is you're making sure that what you have available is works with the demand you're receiving. But the thing is that that's a really complicated question. Like, sure, I know that during Black Friday in the US, I'm going to have a big spike in stuff coming to my world. I know for a fact that 11/11 day, I'm going to be having a huge spike, and in fact that those teams spend the entirety of the year getting ready for that day. Right. But I also know that maybe something happens, like I was suggesting, where all of a sudden something happens that makes my service become really popular. People all want to buy the swag, the Sarah Kong, designs on on our website, and it has a huge spike. And so what are you going to do about that? And so you have to sort of plan for scaling when possible. And I think that's just important to know, but it's not trivial. Sometimes it's expected, sometimes it's not. Okay, keep on going. This is basically saying there are two flavors of scaling. One is to get a bigger one. One is to just say I need a bigger one. The other one is to say that instead of having one big one, because after a while you run out of how big you can get, I have a bunch of smaller ones that are going to take the load, right? Like, so that's either scaling up or scaling out, or scaling vertically versus horizontally. Horizontally is, I'm going to shard my load over a bunch of smaller ones, and that's the only one that really, quite frankly, scales, because after a while you run out of bigger. Okay, keep on going. So again, this is all about scaling. So
just one last thing about scaling.
Yeah.
So one of the things that we've talked about in different series is things like around scale sets. So a scale set's interesting because I think the way I understand a scale set is it helps to kind of manage how quickly or in what way you go about scaling. Because there are aspects where you may not want to scale too quickly, or you may want to scale at a certain pace. So can maybe talk a little bit about what it means to have these scale sets, especially within a policy.
Yeah. I think the reason why this gets complex is that for two reasons. One, scaling can go in two different directions. Let me just state that first before we get further, right? It's okay to scale up, but when, Sarah's designs aren't nearly as popular as they used to be, and no, I'm not throwing Sarah under the bus, friendly folks in the chat, you might want to, that time, scale down again, right? So there's scaling up and scaling down. We just have to make sure that's the case. There's also the question that says, if I have a brief, you want to make sure that you're scaling properly when you have spikes, right? Because it may be the case that it's just a spike, and if you are always responding to a spike, you may not be scaling, in a way that is sustainable, because it takes time to scale, right? To bring more things into your scale set, to bring up more instances to handle stuff, it's going to take time. And so it isn't the case that you can assume that I can instantaneously scale. Oh no, I can go from 1 to 1,000,000 in no time at all, right? You have to work it out. And typically people do that in tiers in many ways to handle this. So I hope that answers your question, right? I just want to say that the reason why you're bringing this up is that, like, understanding things like cool off periods, right? Where you're like, okay, I'm not going to make another scaling decision for another 5 minutes because I know things are so variable that if any decision I make wouldn't really make any sense. Like, that's the sort of thing that when you get into the land of scaling, that you start thinking about pretty heavily. And understanding your traffic is really useful to do. And the internet's a fun place when it comes to this.
Yeah, and so what we're describing here is a lot of the concepts and decisions that are made in the performance efficiency pillar. So we'll get to it in a second, but what we're talking about are different types of recommendations that we would make in the pillar that you can then use for your own strategy for scaling both out and in. So it's an important part of this particular pillar.
And I also think it's useful to understand that depending on the kinds of loads you get, you may choose different resources to be doing the serving than other resources. So let me give an example of that. It may be more advantageous for you to use something like Azure Functions, or these things where you only pay a tiny fraction of money when somebody actually sends you a request. So in that particular case, you're not scaling by saying, give me another bigger one of this, give me a bigger one of that, and my costs have to jump by huge levels. Instead, you can use something that is sort of in some ways auto scaling, right? In theory, when you set things up, again, there's more details into this, but you set stuff up. Basically, that means that you're not paying for something running all the time. You might, again, there's some nuance in this, and that you might want to warm up your world so things are responding quickly. But in that case, you're just saying, okay, well, the difference between answering one request a second and 1,000,000 requests per second doesn't mean that I had to provision up this many VMs to support that. So I just want to say that sometimes your choices of what you're going to use will have direct impact on scaling and cost when it comes to scaling. And you want to, and you'll be thinking about this pretty carefully when you're doing it. So
Yeah, and one last point to that is, and
yeah,
back to the slide is, when you're dealing with like componentized architecture or microservices based architecture, what you also have the capability of deciding of the workload that you're running, what parts need to scale out more quickly or in a certain way than other aspects of or other parts of your other components of your workload, and which is really nice. It's a nice level of flexibility that you can bring to your workload because now you can decide what needs to be more performant when, and when to scale back at other times. And so that application, because it has potentially so many different use cases, you want to be able to architect and understand the provision, the scaling out of that particular application or the for the use case in mind. So
yeah,
it's
yeah,
not.
that's totally right. I mean, because for example, you might have your front end scale a lot faster so you can take the orders, but actually process them asynchronously a little bit later off of a queue means you don't necessarily have to have a 1-to-1 ratio where an order comes in and it's immediately ready to be processed. It can be queued. There are other techniques, and this comes up in the architecture center as well, with like things like caching. Like
Right.
it may be the case if I throw a good cache in front of it, then I don't need to have 14 or 1400 servers in front of it. I can have 3 that talk to a fast cache and can get answers. So anyway, it's super fun. So this is just saying, in the world where we have when we have architectures that include microservices and etc., one of the things to understand in this highly connected world is that it's a terrible idea to have your network be slow. And it's not that we're saying like buy the 10 megabits per second versus 100 megabits per second, to go back in time here, cable. We're just saying that like it's not a great idea to, for example, throw all your traffic from one side of the globe to the other, because there's the speed of light considerations, right? And so you want to make sure that if you have all these interconnected things, which I'm almost certain you will and do, that you make sure that you are thinking hard about that and that connectivity. And whether you do so, that has to do with like making sure you keep your processing in a region, making sure that that you're just handling this. And it gets harder when you're doing multi geos, for sure, but you want to make sure that you're really not going from across the continent or from this Azure region over here to Azure region just to get the answer to something that should be really quick. So, and that's where caching can come in place as well, for sure. Okay, other stuff. Storage performance. Yes, right? Same deal.
Yeah. Yep. And I think the other thing to point out with this, and as we're talking through these pretty simplistic slides, where you're going to find a lot of these concepts are in the actual design principles, or the principles that we'll be showing in the demo. These are essentially fundamental, universally applied design principles that can work with any workload. But they also need to be considered. So that's the reason why we're bringing these up. Is these are just things that you need to constantly remember, constantly apply when you're thinking about your workload. And thus, the well-architected framework starts at this level. It starts with this highly kind of simplistic understanding of the various characteristics of the workload design. And so we'll get deeper into the actual into the framework itself, and just as soon as we're done with these slides.
Yeah, I mean, it's not that these slides are bad, but
Right.
I think what Ben is pointing out is like the thing I just said about watching your network and making sure you're not tossing stuff across the globe from region to region. It's not because it's very easy to do by mistake. Mm-hmm. It's very easy if you're already in multiple regions to be putting stuff in and not thinking about your traffic flow and that sort of stuff. And it's not because, and so when I say this, I'm not trying to say, listen here, dumb, like make sure you don't do dumb things, right? Because that's not it. It turns out to be like very smart people, myself included, or maybe I guess I'm not in that category, but other very smart people that I've met have made mistakes about that sort of stuff just around this. So it's not bad to have somebody tell you, make sure that your storage is partitioned properly, make sure you're sharding it properly, right? Like it may be the case that you don't need to have your entirety of your database next to you, right? And it may make sense that you have different shards and other geos. Like there's different ways to handle your data. And this is just trying to say that like you have some flexibility. It's good to be reminded that even if you've been doing this forever. So, okay.
Let's keep moving.
So yes, right? Like this is an obvious thing. Like, and this again sounds easy and it's not. That's where I suggested the Systems Performance book by Brendan. It's like the best book I know. It's also really thick on performance bottlenecks that you want to take a look at. Take a look at. Use the tools that are available to you. For example, Application Insights has like a map that is just phenomenal. That shows you like average latencies. That shows you how much traffic you're taking and where and stuff like that. And the first time I saw it, I thought, gosh, this is magic. Just because it really gives you a sense of like what's going on. It also assumes that you also have a sense of what your baseline is, right? So there's a lot of stuff to this that we're eliding, and we just want to make sure that you understand that we know that these are simplistically said, but sometimes more complex to pull off, which is why the rest of the stuff that's there is there. Okay, next one.
Okay.
A knowledge check.
Yeah.
Which of the following is an example of scaling up, i.e. vertical scaling? A, updating your application to use a queuing service. Well, that's interesting. B, adding more web servers into a web farm. C, adding another virtual machine into a database cluster. Or D, updating a virtual machine to a larger size.
Pretty much that one seems pretty obvious there.
Yes, that's right. Yes, we did say making, embiggening, as we like to call it in the field. I made that up, by the way. Okay, next check, please. Which of the following is an example of scaling out, i.e. horizontal scaling? Updating a virtual machine to a larger size. Hope you're paying attention to the previous knowledge check. B, adding more storage to a virtual machine. C, adding more web servers into a web farm. Or D, replicating backups to another region.
That one seems pretty obvious too.
Yes, and I just want to say that you could get a little tricky here about D, in that if in fact it was replicating see, that's why it says backups. But if you're saying maybe keep replicas in another region and have a bunch of replicas, that would also be horizontal scaling from a database cluster perspective. If you have a bunch of replicas and you have read replicas and you read from those, that's horizontal scaling. So that would be legit. If anybody here was like, So
okay. All right. I think we have one more to go. So our favorite topic.
I'm imagining that I run a clinical system for a healthcare organization. That's all you need to know about reliability. Thank you for coming. What is reliability? Well, this isn't what reliability is. Again, to me, so we're going to get to this part here. Reliability to me, again, is matching expectations, setting them expectations. In SRE, we talk a lot about coming up with the appropriate level of reliability for a system, right? Because, having something be up all day, 24/7, 365 may not be important for something where you're running one report on Thursdays. Right. And so spending all your time and having people on call just so that, like, if there's a problem with the report system, like someone can respond to it instantly at 2 a.m. may not be a good use of your money. So reliability is about, meeting those expectations at the appropriate level. So if you want to build a highly available architecture, this is just basically saying like, hey, it's more available if there's two of them or more of them, and that you have some way to load balance. So like if something goes wonky with one of them, whatever they are, you take it out of rotation and you give the load to other ones. So simple ideas about that. So
one question about this, this goes back to the shared responsibility stuff, is so there's several different levels of a service level agreement. So like there's a service level agreement between Azure and the customer. There's a service level agreement between the customer's workload and the users. So how do you relate the two? Like, how do you do they stack? Do they integrate? Like, how
Well,
do,
allow me to make this worse for you
okay.
before I make it better. There's the different SLAs among the different components that you are using to build your application. So you might get a different SLA out of the Cosmos DB team than you might get an SLA out of the app service team. I don't know if this is actually true, but I know they're different. Like I know which, comparatively speaking, right? And so basically what you have to do is collect SLAs, and you have to sort of look at, in many ways, what is the least promise. Like SLAs are meant to be agreements. They're legal things that say, I promise to you that I will deliver a service with the following characteristics. And if I fail to do that, I will somehow do something to compensate you besides just saying sorry. Right. And because I'm willing to put that money on the line and I'm willing to make this agreement with you, I'm telling you that I promise I'm going to be up this amount. Right. And so you shouldn't be promising downstream anything more than you've been promised, is the way I would say about that, right? Like it's one of these things where if somebody says, I promise to be up only on Thursday, you shouldn't tell your customers necessarily, right, if you depend on the system, that I'm going to be available all week long, right, is the way to think about that. So your dependencies matter a lot about this. And so what you're going to relate to your customer has to be, I don't know if the word looser is the right word, than what you've been promised. There are ways to make yourself more reliable than your dependencies, and sometimes that works and sometimes it doesn't, like caching and other stuff like that. But if you're in a situation where in order for your service to work, your payment processor has to be working, and your payment processor is down and you have only one of them, then you're not going to be able to take orders or take money in, right? And so you need to look at what your payment processor, and that's why people get multiple payment processors, and they make it so they can switch if there's a problem, right? So I think that they do stack in a particular way, but the thing to realize here is that it's you can't overpromise based on what you've been based off of what you promised, unless you've done really extra special work to do that, is what I would say about that.
Okay, so if I heard correctly, you look at all the different SLAs that your workload is meant to be utilizing in some manner, and then based on those SLAs, you provide your own SLA to the customer or to whomever the user base is. Is that
if you choose to do that, that's right. You might certainly do that. Based on that, that's where you're going to get that plus your knowledge of the architecture of your system and which of those things. So, for example, if one of your things has an SLA that's not so great, but you don't use them very often, or they're not crucial as part of the purchasing flow or whatever, then you can take those out of your have that be part of your equation in a different way than the thing you depend on that must be up absolutely no matter what for your website to work. And so that's where you're at. That's where you're. Yeah. So the direct answer to your question is yes, you had that right, and it's more complex than we're talking about.
Okay. Okay. One last question to this, because I know we want to get on. We've only got 26 minutes left. If you were to look at an RPA versus an RPO, like how do those two metrics, like, and first of all, what is an RPO?
Why don't you expand the acronym first, Ben, before I answer the question?
Well, I don't know if I can. I think one of them is related to like how resiliency is described for the application. So if the application is running for and it goes down, how quickly can that application come up? Or more importantly, what's the potential impact of the experience the customer or the user is having when that application is down? So I think I got that correct. The other is the actual availability, which is where you're looking at how much uptime does that workload have?
Right.
So if and that's more of an absolute number. But am I thinking about that correctly? Are those? And I'm not sure how what the acronym.
I mean, the way I think about those has to do with how long will I be down before it's a problem? How much data might I lose in that process? Like, so for example, if I am keeping data in one place, I am mirroring it to the other, and and presumably I'm mirroring to the other. Sorry, I'm going to figure out which way it looks good on the screen. Let's try this one. Okay, so imagine I have data over here and I'm mirroring it over there, right? And
Mhm.
so I do it every 15 minutes,
Mhm.
right? That I make copies or I send it, because I can't do it synchronously. Otherwise, people are going to be waiting over here for too long. So every 15 minutes, I send a snapshot this way, right? This says that if I go down, I might lose up to 15 minutes worth of data, right? Because I've lost the snapshot if this goes down, right?
Mhm.
They never get over there. So it's ways of thinking about the question about like, what is the losses? How quickly will I come back? And how much of a hit am I going to take based on the solution that I've engineered? Is what I
Mhm.
want to say in those cases. Because sometimes the answer is it can be zero, right? If we're talking banking, it can be zero. It's like, oh, sorry, I don't know what happened in the last 15 minutes to your money, pal. Like that's not okay. But
Mhm.
sometimes it's okay to say like, okay, well, maybe we've lost the last 15 minutes worth of this sort of transactional information that they're just logs and we don't really care about. They're good to have, but it's not required that we have it for financial reasons. So that's where those conversations come, and I think they're very specific when you get deeper into sort of this question about BCDR is often when RPAs and RPOs come up. So
Okay. 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 Thank you for that. So let's keep moving.
yeah.
So yeah.
Okay.
So there you go.
Build an architecture that can recover from failure. Right. So here we are. Here we are in RPOs and RTOs, which is what you're thinking of.
That's what I was thinking. Yes. Thank you.
Okay. Great. I was like, RPA was not something I knew, but I was willing to roll with it because I thought maybe that's another word for it, or maybe it's a kind of root beer. Anyway, so recovery point of objectives, right? So this is the thing. This is like 30 minutes later and stuff like that. It's how much data loss you can take. And RTO is the maximum duration of acceptable downtime before things are bad.
Right.
And that's, again, this is in the BCDR realm, which I think is slightly adjacent to reliability, if you really want to know.
Mm. Oh.
Still at least on the same hallway.
Mhm.
Okay, let's go on from here for a second, since we already beat this off in an abstract way. Okay, knowledge checks. Yeah, I know RPA means a lot of things, Alan. I don't disagree with you.
Yeah.
Suppose you want to increase the availability of your system to provide a better service level agreement to your customers. Which of the following is a guiding principle you can use? Reduce your target for maximum duration of acceptable data loss. B, encrypt all your data at rest. Or C, eliminate single point of failure.
Hmm. Oh, that one seems pretty obvious too.
Yeah, well, there it is. Failure, etc. Next one.
One thing that we will talk about in a minute is when we talk about like the trade-offs of this is actually an area where we would focus on is how do you think about trade-offs for reliability? So you would want to ensure that there's some sort of you don't have a single point of failure, but that also suggests that you're going to probably have like redundancy somewhere, or you're going to think about well, I'll just use redundancy as an example,
Yeah,
but
yeah,
redundancy is going to actually affect how much that application or workload costs to run, because now you're effectively running two different systems,
that's
maybe.
right.
And so you'll need to keep that in mind when you're thinking about how critical is this application. What does the service level agreement need to be in order for you to run this application, or what is this, how much infrastructure do you need to support this service level agreement? And so
Yeah,
it's an important consideration that we haven't brought up yet.
yeah. One of the things that I really like about WAF 2.0 is it has explicit guidance on the trade-offs you're making. You gave one of them, which says it costs more to have two of something, right?
Mhm.
But it's more interesting than that, right? Like it's not only cost more, there's also, you might change the way you do things.
Mhm.
If you have to have like one of your backup thing living in another region, you might have
Yep.
to figure out what things are synchronous, what things are asynchronous. So there's more to it. But yeah, there's reliability definitely comes with a cost, but also losing your data and not having your customers be able to use your application also comes with a cost, right? And that's the cost that people are looking at that says, yeah, it would be very bad for a lot of things, including our business, if this no worky, and so I think that that's important, and that comes about other places. Performance is the same thing. It costs more money to bring up a caching layer, right?
Mhm.
But it might make it so that you don't have to have as many servers, so maybe it's cheaper in the end, right? So there's some really fun little trade-offs, and it's living in those trade-offs is what we do for a living in many ways, right?
Mhm.
Is understanding those trade-offs so we can express them clearly to the business and say, like, what's important to you, this or that. And often the business doesn't really like making those choices, but it has precious little choice in my experience. Okay, let's move on to the next stuff.
Okay.
Which of the following is affected by your defined recovery point objective, RPO? Frequency of data backups, number of regions, number of instances, type of load balancing technology used in your application. There you go. Right?
Yeah.
How that was the question. Like, if I have to replicate it, how much time do I have in between? Or if I have to go back to my backups, how recent are they? Is kind of a really good question, which is where it comes into RPO land. Okay, next item, please.
Okay, one more.
Yep. Yeah. Well, no. I mean, is security important?
Oh no, let's just breeze through this one.
So, healthcare organizations store personal and potentially sensitive customer data. Really? Okay. Well, let's keep on going and find out more. Security is ultimately about protecting the data that your organization uses, stores, and transmits. Sure. Okay. I mean, yes. I mean, it's not just data, but sure. I mean, there's other stuff that security involves, resources, assets, other stuff like that. Maybe it all comes down to money. Ultimately, it's protecting the money, maybe. And it basically says, like, hey, here's the cool thing. In order to do security well, it can't be that you have one big locked door and everything else is out there in the open, right? It used to be what we used to call like like a chewy middle situation, like candy, like a hard candy with a chewy middle. It's like, you can no longer rely on, for many reasons, just having a moat and a big wall around your city, etc. So I guess that's the thing. That's the thing to understand, is that it's no longer protect the gate from the Visigoths, in a way it used to be in many ways. So okay.
Yeah, and I think with defense in depth, this is something we talk about a lot in security, and like zero trust is another big one. But defense in depth is interesting because what we're really talking about is ensuring that there's varying levels of security, so that you lock the doors, of course, but then there's also the other aspects. So policy, understanding what your policies and access need to be for your identity access management, for instance, and then also your networking and perimeter security, along with, and then further down into VMs, applications, and data. These are all going to be important security layers that you need to have in mind for the application. So there's all these different contexts that you need to consider as you're designing this application. And so that's where the security pillar makes a big difference. It's really getting into these considerations from an application perspective or workload perspective.
Yeah, and I think you hit on it like really brilliantly when you said it's context. It's about contexts and managing those different contexts, and as you go. Let's see more about what's here. So this is just basically saying that there are a lot of common attacks, and because they're so common, you probably know about them. But there's also a lot of cool non-common attacks that you have to protect against, and in many ways, some of this involves availing yourself of the tools that make it easy for you to do, because it's not always the case that you personally can do it, right? So an example for that is, it's in your best interest to, in addition to you maintaining it, having someone like Microsoft keep up to date a set of rules that are in a web application gate, firewall, like a WAF, right? So it is the case that, like, it's great that you set up your own tools, but you probably don't want to spend all the time trying to figure out, like, oh, I see this, looking at all your traffic and figuring that attack, while we are taking in petabytes of information, hourly, and trying to come up with the best rules to help repel what's going on. And so in many ways, to me, each of these things involves using the right tool. So for example, don't write your own SSL library or TLS library. Use one of the ones that is well known to be secure, right? And when they have an issue, update yours. Try to make sure that things are secure at each of these levels. So this may go to your shared responsibility statement, where part of the job is know what you should be doing, know what you have levers to control and should be using. Like, you could write your own SSL library. People do, and it's really madness. Or you could, piggyback on other people who do this for a living. So I think it's really important to understand to use these sort of tools that are out there. And many of the some of the tools aren't on by default. Like it may be the case that by default, when you deploy a particular resource in Azure, it is available from the internet. And maybe the first thing you do, or as part of your templates as you do stuff, is you shut that down. You make sure it all lives on a VPN, on a virtual private, on a virtual private network, but on its own network. Let's just put it that way, such that it's not flapping in the wind on the internet, right? And so, trying to understand ahead of time how to be secure and what you need to do is really useful. There's some discussion going on in the chat about the different courses, and those courses are also really great ways to get like a handle on like, what do I have to do to pay attention to? How do I watch whether something's gone wrong, et cetera? And so this is just trying to say that there's a variation of attacks. But like, for example, today I was watching a video of somebody who had their car stolen, because somebody can hold up an antenna to just simply amplify the signal between your key fob, which is sitting in your house, and your car. So the key fob doesn't have to be near the car. They just have to be there, pick up that, amplify it so it gets over to the car, and then the car doesn't know you're not standing there, and like, congratulations, there goes your Rolls Royce, right? So, and this is not this sort of that sort of attack is now really, really common. So like that's what I mean by there's non-obvious attacks as well that are super really interesting. Okay, let's keep on going because I want to make sure that we do have a chance, at least in the last 5 or 10 minutes, to show some of the other stuff there. So common attacks, this basically says congratulations, worry about your physical layer, your access layer, and your perimeter layer. I all agree with that. Let's go on from there. Shared security responsibility. Well, look, there it is.
Yeah.
I am psychic. Okay, knowledge check.
Okay.
Here we go. This is going to be great. Which of the following types of data might need to have security protections? Can we just go to D? Can I just not say anything? Like, when's it going to be a thing that says you shouldn't have it? Under what condition are you going to say, yeah, no, I don't care about that? Maybe free stuff you give away. I don't know. Which of the following examples of attack you might see at the policies and access layer? Exposed credentials, SYN floods, following an employee into a data center, ransomware that encrypts the disks of a virtual machine. Well, I can think there's a couple possibilities here. Yeah, there you go.
All right. So I think with this is the last of the questions in the knowledge check. So I think we can actually move on to the demo.
Holy smokes!
Yeah,
I'm all a quiver. Okay, let's go take a look at what the Well-Architected Framework, like. Let's look at the stuff that the people who are watching this, if there are still people watching this, can touch, can do, can find, get this information here. So here we are sitting on learn.microsoft.com. You're on review.learn.microsoft.com. Did you want to be there?
Yeah, it probably doesn't matter, but let me just move over to it.
Yeah, I'm just noticing that. So just to be clear, this isn't like congratulations, we've just given away the secrets of Microsoft. We've just is like a preview version that allows us to do development before we push it into public. Not a big deal. And if you're not from Microsoft, you probably can't get to it. But you can imagine that we have a draft site, right? Like, so that's the thing. That's our big security breach. Haha. See, we wanted to lead something on security. So okay, great. Okay, so hey, Ben, you know a lot about this. Why don't you show this off for a bit?
Okay. All right. So I'll run through a quick demo. We've got about 5 to 10 minutes here. If there's any questions in the chat, let me know because I can't see I can't.
I'll watch the chat and let you know if people ask questions.
Okay. All right. And I know, Sarah, you're addressing the questions too. So just let us know if there's anything else that you would like us to follow up on. Okay, so the reason why I'm coming here first, the Well-Architected Framework, is kind of that all up is this is a new page. This is a new page because what we're effectively doing is putting it all out there in one place. So this is the framework plus a variety of other tools that the framework is based on or aligned to. So as we've been talking about for the last 80 minutes, is the pillars themselves. So you got cost optimization, security, et cetera, et cetera. But then on the other side over here on the right is what we have is the different types of products or different sorts of things that relate to the well-architected framework. So one of the most important aspects to the framework is here, up in this piece here, where we're talking about design principles, checklists, recommendations, and trade-offs. So these are all of these things apply to the workload or to the pillars. So we have design principles in each one of the pillars. We have checklists within each one of the pillars. Recommendations and recommendation guides are basically deeper levels of content that relate to these different design principles. And then finally, the trade-offs, which David brought up earlier, is really where the rubber meets the road in the way you're thinking about designing the workload, because what you need to do with each one of these pillars is relate them within the design. So you want to be able to see different recommendations and how those recommendations are trading off or have considerations about other aspects of the and other pillars. So that's the reason why trade-offs are so important. But then when you get deeper into like how to apply the workload or the framework, that's where you have things like the workload design, where what we have are a variety of different workload designs and reference architectures that are basically using the well-architected framework in a way that helps to quote unquote certify the way you would think of these architectures. And you can find those in the Architecture Center, which I'll show you in just a second. The other thing that we have is assessments. So an assessment is essentially, and I'll show this too, is a way to think about a specific workload that you have, answer questions based on each one of the pillars, and giving different answer choices will determine what sort of recommendations you should see. And the reason why this is a nice little tool is the well-architected framework has well over 1,100 pages of content in the framework itself. And so that's a lot of material to figure out how to navigate. So what we're doing instead is basically saying, use this assessment for a specific workload where you get these answer choices and the recommendations related to those assessments or answer choices. Click on that recommendation and it'll take you to exactly what you want to see in the framework. And I'll show you, I'll do a demo of that in just a second. Finally, advisor recommendations. So if you know what Azure Advisor is, it's basically a tool that uses telemetry from the use of various sorts of services in Azure and also the resources that you have in a subscription, and basically gives you recommendations on how to better utilize those resources or how to configure those resources based on the workload that you have. So these recommendations that come from Advisor are based on the well-architected principles and well-architected pillars that we're showing. So it's a nice symbiosis between how to think about the architecture and the design principles and the actual implementation recommendations that are coming from Advisor. The last thing here is service guides. So service guides are actually super, super cool. We had some of these in the first version of the well-architected framework, but now what we've done with service guides is we've really built out service guides for all the different pillars. And so what they do basically is they are giving you very specific guidance in how to think about configuring a service, an Azure service for a given workload and within that, or for a given design of a given workload. And so why that's so important is what you want to do, and kind of what we've been talking about this whole time, is you want to have a good understanding of what that workload needs to be, the design principles of that workload. But really what you want to get to is how do you configure this service for that particular workload using the principles in mind.
By service, you mean like Cosmos DB, just so we're being explicit about this?
Yeah,
like,
exactly.
Or app services, or I don't know, Kubernetes, or that's what we mean by services when we say that, right?
Yep, exactly. And I'll show you what that is in just a second. So let's actually dive in. But before I do that, actually, I just wanted to share one last thing, is workloads. So one of the things about the well-architected framework is it's meant to be a framework that's universally available or universally applicable to all workloads. At the same time, however, each workload is going to have, or workload type is going to have its own set of recommendations and design principles that should be applied differently. So what we've done is to basically help shortcut your own design is to look at different workload types. So for instance, we have one for Oracle on IaaS. So this is if you have an Oracle workload where you're hosting it on Azure, then what you may want to be doing is architecting it in such a way where you are utilizing the principles around Oracle or the architecture around Oracle most effectively. The same goes with SAP. Go ahead.
So Ben, I'm going to be really sad if in the last 4 minutes we don't get a chance to show somebody the trade-offs.
Okay, let's do it. Okay, fair enough. All right, so you get the picture. So let's go back up here to the architectural design, up to the top here, and let's just click on pillars. So when you click on pillars, what you're first going to see is all the pillars. So you have an overview. That's kind of what this is showing here. And then you have the 5 pillars: reliability, security, cost optimization, etc. Here you've got the overview, which will also do the same thing. What we find most useful, however, is to use the table of contents to basically go through the content more effectively. So let's just take reliability. So in reliability, there's this quick links. In quick links, what you basically are able to do is look at all the different learning capabilities, or learning opportunities. So there's these different quick starts. There's an actual training. So this training is a learning module that you'll find in the Worldwide Learn platform. So you can actually go through a learning path in this way. There's specific videos, like this one here is of Mark Rusinovich talking about the data center architecture. And so it gives more detail. And then there's the actual principles themselves. So these are the design principles, many of which you'll have already seen that we talked about today. And various aspects of things like test and design, which are specific to reliability pillar. And then there's various how-to guides. And these how-to guides can be very, very helpful as you think about the workload itself, and then how are you going to actually go about implementing this workload. So design principles. So design principles are effectively the way you think about your design. So this is where you think about the strategy of this workload. How important is reliability for this particular workload? The criticality of the workload, for instance. What's that service level agreement we were just talking about? What does that need to look like? How do you support a service level agreement of that nature? When you kind of get that sense, what you can then do is move more deeper into what we call a checklist. So as David was mentioning earlier, one of the things that we all know, architects and developers are pretty smart people. They know what they're doing when it comes to the design of their architecture. But at the same time, it's good to have a checklist. So you kind of get a sense for, have I checked all the boxes? Have I overlooked anything when I think about how this design is going to be, and specifically within this particular pillar? So what you can do with the checklist basically is run through all the different recommendations that we make for this particular pillar. So in this case, there's 10 recommendations. What you can do is then click into one of these recommendations to kind of get a better sense for what it means. So what we call this is a recommendation guide. So the recommendation guide basically takes you through a very, very detailed set of guidance that will give you a better sense for how to think about this particular recommendation. At the end, what you'll have is, let me show you here, is Azure specific guidance or Azure facilitation. So Azure facilitation is essentially going to be describing how to use or how to think about using the various services within Azure for reliability purposes. So here we have Azure Monitor and so on and so forth.
So I, again, will be very sad since we're actually basically out of time. If we don't show one of the trade-offs.
Promise, okay.
As a way, and maybe this will just be the thing that gets people to be wanting to check out more of what's here. But
Okay.
basically, this is really cool because this is the first time I think we've really done a good job of documenting the fact that these two pillars interact with all 5 pillars interact with each other, and how to think about it, because this is what the real world is like. So,
True.
and I think we do a really good job of documenting that. Is there anything you want to say, Ben, as sort of a goodbye to the fine folks who stay with us and listen to us? Besides, like, go check this out. It's the bee's knees.
Yeah, yeah. I think what we're saying is kind of the crescendo of this presentation, which is really go check out the well-architected framework because of the trade-offs. It's
Okay.
one thing to be able to look at each one of the pillars individually and get a sense for how reliability should be implemented or thought about, but it's really how to think about all of the pillars combined in a holistic way for a particular workload, because it's there where you'll see certain trade-offs that really make sense. And it's that intelligence that you get from proven guidance that will allow you to move faster and allow you to give you more confidence in the design that you put in front of the architectural community. So I'd say that that's the main thing, is really focus on the trade-offs and the holistic nature of your design. So, and that's what the well-architected framework is for.
Cool. Well, I think with that, what we need to do is let people know to make sure that they check out the next episode that's coming up, which is next Wednesday at the same time. So I hope you'll join us. There's a link that you can see that's been scrolling across the bottom of the screen. If you want to check out the next episode, I want to thank you on behalf of me, and I suspect Ben also is equally grateful that you had a chance to sort of hang out with us and talk with us about well-architected framework. We're really super into this, and we really appreciate your time. Oh yeah, here it is. Here's some things about that allows you to get there. Next steps. Yeah, check out the Cloud Skills Challenge, register for another virtual training day. Make sure you check out everything Sarah does, and please thank her if you would in the chat, because she rocked this entire time. And we're grateful to you for watching this. Thanks, everybody. Have a lovely day and a lovely night, and take good care.
Thank you
Now
all.
let's go back to waving.
Bye all.